See, with the help of certain tools, we wanted to do data engineering. Like we have tools like Databricks and Snowflake. This is the idea in the session, right? But before I start the session, see, uh, if you might have seen in the last almost a decade, more than that, I will say, there is an urgency to train on certain technology. So if you have seen that in industry, everybody wanted to upgrade on, and most of our projects are majorly on technologies like AI, data engineering, big data and, blockchain and IoT. Have you seen this trend? Like everybody wanted to upgrade on these technologies, and almost all the projects are on that only. So, any reason behind that? Anybody would like to give some inputs? And let's try to make this session little interactive. We all are discussing here. See, I will learn from you guys, and the same you will. So we'll try to make this session little interactive. Please participate in the session, all of you. Um, yeah.
It may be because of a huge data volume out there and the various methodologies to, process that. Uh, right. So, like, how can we process that huge chunk or volume of data? And in what way it could help, the business to get really good insight out of that data.
Mhm.
And
Yeah.
so varieties of data as well, structured and unstructured.
Mhm.
Also, I think these technologies are need of our, as in like, all the new applications, solutions are building around that, right? And your high paying jobs are also
Correct.
around that. So, yeah.
Correct. See, okay.
Also the fast retrieval or fast
Of course,
ingestion of
of
data
course.
and less coding.
Of course, that
That's
is what, yeah, yeah, right. Of course, this is a need of an art. We want it to be more fast. We want it to be more, like data driven. That is why a lot of technologies are getting upgraded. A lot of technologies are there. But like the technology that we are talking about, like AI or these things, of course, what we have achieved today, it is very far beyond that we had earlier, but these technologies are not so new, right? We are just upgrading again and again. And AI has been coined by Alan Turing somewhere back 1940s, right? And then almost I will say like all the big deep learning algorithms has been developed back somewhere in 1990s. And in beyond that, even though neural networks and almost so many things. And today, what the data engineering that we are doing, so many developments had was already there. Okay, but today we wanted to scale it on a very large amount of data set. We wanted to get a lot of intelligence out of the data. The actual reason behind that is, uh, industries are upgrading on certain technologies because there is a revolution happening right now in industry. And this revolution right now is called Industry 4.0. Have you heard about it? Anyone here?
What was that industry?
Industry 4.0.
Industry 4.0.
Yeah. So basically, this is the fourth industrial revolution. It's a fourth industrial revolution of technology. Okay. Industrial revolution of technology that is happening now. Okay. In today's days, right? And the idea behind this fourth industrial revolution of technology is, by utilizing certain technologies, okay. Whenever industry upgrade on any technology, there is a very simple idea behind that to increase the productivity, okay, and increase the productivity and decrease the efforts. Okay, anytime from the law of, long way back, if you see that, from the first revolution. So of course, if there is an industry 4.0, of course, 1, 2, 3, and 4 that we have right now is there. Okay, so let me take a moment of time and just allow me to give you a kind of an introduction of around this, because almost everything that you are supposed to gonna learn throughout in coming days, or what you are learning throughout, this is totally based on this fourth revolution of technology that is happening now. So if you might have heard, like the very first revolution in industry, okay, uh, when we say revolution in industry, means industry wanted to upgrade on certain technologies so that they can reduce the human efforts and increase the productivity. so that society can get benefited out of it. Okay, whatever applications you are making, you wanted to get this benefited to the society, right? We all are connected to this. So how it is happening, the very first revolution, industrial revolution, happened back somewhere in 17th century, in the mid of 17th century, when we got very first steam engines and weaving machines. So when we got these technologies, with the help of this, we created some applications. Okay, we created railways, we created small factories for weaving machines and something like that. Whenever we have technology, we create applications so that industry can get benefited. So that was the idea of Industry 1.0. Okay, this is the first industrial revolution happened in industry. The second industrial revolution, the Industry 2.0, happened in the late 18th century, or you can say in the beginning of 19th century, in which we did two major things. One, we did mechanization, and second is called electrification. So with the help of mechanization, we created big automobile industry, and then the whole big industries were growing, like chemical factories, and different factories were growing where all the motors and conveyor belts, and with the help of those kind of technology, we were able to achieve reducing the efforts, and the whole industries were revolving around mechanization and electrification. And this second revolution is called as machine age. With the help of machine, they wanted to reduce the efforts, and today with the help of machines, a lot of industries were growing rapidly, right? This is why this was the idea. The third revolution is the more, you can say, uh, what we have not upgraded till now in 4.0, but we wanted to. But the third revolution is the most fascinating revolution happened. That's called Industry 3.0. And it's happened in the late 19th and the mid of 1950s. What happened in Industry 3.0? Anybody would like to guess, or if you're aware of that?
It is when the computers were
Birth of tuning machines.
yeah.
Correct. When we got semiconductors, okay, we created electronics. We had electronics. When we got electronics, we created computers. When we got computers, we did automation. Okay. And what is the meaning of automation? Automation means anything
Manual
that is
process.
self-driven with some human intervention. Correct? Means with the help of Industry 3.0, we did an interaction between a machine and between a human. A human can program a machine in as such a way that this machine can take, some certain operations. Like giving you an example of a coffee vending machine. Let's say you require a cappuccino, you have programmed the microcontroller of that vending machine in as such a way that some more water, milk will be poured in a cup of jar, and then you get your cappuccino, right? Or whatever you see around. We had made an interaction between a human and between a machine. Machines can be instructed by human what need to be done. Okay, so human had an intelligence that has been given to the machine. That's what we done into Industry 3.0. Did you understood? Yeah.
Yes.
Yes.
Yeah. Now what's in Industry 4.0? This is the more fascinating one, and we need to understand because like, let me just tell you. Industry 4.0 is the fourth industrial revolution that is happening in industry. Okay. And the idea behind this, okay, so the Industry 3.0 is called as information age. Information age. This Industry 4.0, the idea behind this Industry 4.0, in the third revolution, a machine is being instructed by humans that what need to be happen, okay, by giving certain programs, by certain logics and all. In Industry 4.0, we want there should be a machine to machine communications. Means machines should be enough capable to take their own decisions. This is what we want in this industry 4.2. And that is why this industry 4.2 is called as intelligence age. Intelligence age, right? We want machine should be enough capable, your X-ray Mueller sensor should be enough capable to do the diagnosis and, understand like the expertise, uh, you know, a doctor do have. Similarly, the based on the data, based on the algorithm, based on the analytics, based on the, different reference learning, transfer learning techniques, a machine should be enough trained on data and in a continuous process of learning that it can take the decisions, that it can give a depth diagnosis results, or a generative AI should be enough capable to understand the human sentiment and based on that can able to react, or it should be enough capable to to do anything, any manual task that is being done by any machines or a by a human. Machine should be enough capable to replace that, or at least reduce the efforts of a human by keeping their own intelligence. That is what the idea, that's what we wanted to do in industry 4.0, and that is why it's called as intelligence age. Understood? Do you have any question? Yeah.
Yeah.
Great. So because of that, in industry 4.2, there are multiple technologies that you're hearing. Either it's a DE, either it's a data science, either it's a IoT, either it's a blockchain, either it's a cyber physical system, either it's a, AR, VR, or there are variety of technologies. These technologies are integrated in as such a way so that it can do kind of a advanced decision making capabilities with the help of sensors, actuators, with the help of data. They by ingesting the data, analyzing it, doing a transformation of complete understanding of different columns, and then allowing us to do it in a distributed form, and then can create a very beautiful applications, and debug for our society. Um, there are a lot of examples of this, application examples. I will take a reference of your, since you guys are from healthcare, I will just suggest you an application. See, of course, there are a lot of diagnoses there. Let's suppose LabCorp is associated with n number of vendors, and in future, and let's say if somebody got for a diagnosis, and if the guy or the organization, let's say you are a direct partner of TCS or a direct partner of any other organizations to doing their employees analysis, employees diagnosis of their blood reports, right? And you did a partnership with them, and then now let's say in the organization, what kind of meal need to be prepared for their employees, that can be decided based on that data. So these kind of basic analysis can be done. Or let's say while you are ordering food on Zomato, and all the by 2025, we all human beings are almost connected by 9 to 10 physical sensors, by your mobile phone, by your smartwatch, or maybe n number of data that we are procuring. So let's say if we can build this kind of features, like based on our sleeping activity, in future we can have a calories intake sensor, what kind of calories you're intaking, or in future we already have SpO2 sensor and multiple other sensors of data that we are able to do in our smartwatch today. It's tracking our activity of sleep and everything, and then the kind of foods or suggestions or recommendations you're getting based on that, or maybe your doctor is giving you a notification, come for the diagnosis for this particular thing, you may can have this problem in coming future. These kind of applications you will see around in coming future very soon, and it's happening. I have seen that in Healthify Me app, if you have ever experienced, these tech has been now connected, and sure you all are already been developing these kind of things. So I'm just telling you like how the age of industry revolution is going around, and things are moving. So this is the idea, and that is why we all are eager to learn technologies like what you are hearing a lot: AI, ML, data science, data engineering, whatever we have, right? So we, as in this session, will be going to discuss heavily on data engineering, and bit of data science, because in in our Databricks there is an API of ML is also there. Okay, of Databricks there is an API of machine learning. So I will also include that in your case studies or project. So we can discuss this both thing. 95% is on data engineering, just 5, 10, 5, 5, 7, 8, 10% on data science as well. So you can have a case study experience. You can have an actual experience of debugging the doing the case studies. Those who are very new. So this is the idea. Uh, Good enough. You have any questions before we start?
Yes, Dipesh, I have a question.
Mhm.
Yeah. So as we see different industry revolutions, right? So difference between different, industry revolutions was quite significant, as in like couple of decades. So do you think, the future industry revolutions which will come, will have very less, difference of time, or do you think, we still will have like quite a long time, to be in one, stage of industrialization, right? Or do you think the difference will decrease as we go forward?
See, this idea of Industry 4.0 revolution being started by a few industrialists like Siemens, Fano, Kuka, they have started this idea to, in the major into the production line, right? So, first for the manufacturing kind of industry, they initially started this idea of Industry 4.0. But sooner or later, that has been assimilated in almost all the industry, and you take an example, every single industry now following this. From the, if you talk about a small, medium-sized industry to a very larger scale industry, everyone is talking about AI, either for development or either for uses. So what I have experienced, since I have an opportunity to interact with a number of type of industry, I have been associated with almost like more than 100 plus types of industries in my career. So what I have experienced is everyone is eager to upgrade these technologies, and they are finding some kind of a solution. They are finding some kind of a API solution, or maybe developing something by their own. But they all are progressing. So in future, you will see that everybody is supposed to gonna use these technologies, and they will be trying to solve their problem or decreasing the efforts. Otherwise, they will be, not so efficient in coming future. So yeah.
Okay. Actually, my question was more around that, the difference between revolution will decrease in future. For example, if we go towards, industry revolution 5, 6, so the difference will increase or decrease, right?
Yeah, there will be a decrease. I will say decrease, because now we are into intelligence age. Now what the next can come is we either can speed up the process like quantum computing, right? So with the help of quantum computing, we will be increasing the processes that we are following in Industry 4.0. Or, in coming future, we can assimilate BCI. If you have heard about already, if you BCI, brain computer interface, where we'll be trying to, make this more interacting with brain also. So these kind of things may can happen, but not so much differences will be there, rather into input process, because AI is already we are doing in 4.0, right? What next is just to scale on a very high or decrease the amount of time. So this may could be an idea.
Okay. Yeah, Dipesh, thank you.
Okay. Anyone else have any question? Okay, good enough. So now talking about data engineering, just a second. Yeah. So those who don't know the role of a data engineer, uh, a data engineer is the one who is, responsible for collecting, pre-processing, preparing the data, analyzing the data, gaining insight from the data. This is the role of a data engineer. But apart from that, there is a structured process of doing this. So anybody would like to explain what is data engineering, since we have a lot of data engineers here. So everybody can come on the same page.
So basically, when they speak about data engineering, right, it's mostly of a conversion from a raw data into a understandable or a standard format where it can be used by the other teams. Like, when data analytics folks want to see and get the analytics out of it, they need it to be in a formatted way or a standard way. So as a data engineer, more of a role comes into understanding the raw format and making sure that it gets converted or formatted in a way that is utilized by other systems or interacted by other systems. Make it a usable data kind of.
Correct. So we can say that a data engineer is the one who is responsible for, collecting the huge amount of data. Okay. uh, Gaining, understand the data basically, uh, transform the data by pre-processing, refining the data, bring into the usable form, store the data, explore the data, and then submit the data or present the data. This is the idea behind the data engineer roles, right? But what it is seems to speak, it's very different way, you all know, right? So we are dealing with very, very huge amount of data when we talk about the different, like industry, um, they come across very variety amount of data. So data itself is a bigger challenge, right? So we'll first talk about what is data engineering. For those who are very beginner to this, let me tell you the processes that a data engineering do have. So a data engineering complies with certain process. So we have data. As you know, data is a raw facts and figure. When we have a very, very, very huge amount of data, very, very huge amount of data, and the idea behind to clean this data, what is the idea behind? See, data is there, data is everywhere. We collect the data from multiple sources. Why we collect the data? What is the reason behind that? If anybody would like to explain why we collect the data, what is the major reason behind that?
We need to gain insights from that data basically.
Of course, we wanted to use this data for our business decisions,
Right, decision.
right? We wanted to use this data for business decisions. That is why we are collecting the data. If you don't collect the data, there is no data. Means we always say that there are more than 95%, 80% of data that is unstructured. These are unstructured because we are collecting. If we won't collect, this amount of data will not increase. And why we are collecting? Because we are into this intelligence age where we want a machine, a laptop or a system or a computer or a coffee vending machine or a AC or a bike or a car or a health analysis machine or anything. Any smart machine should be capable to take their own decisions, and anything can take decisions only and only when they can actually capture a desired amount of data. Let's say if we are talking about a data that what we say X-ray machine should take is like what they take from while they are scanning. They can actually pre-process with the help of computer vision or anything. They can take those images data into RGB format, and then they convert into numerical form, and that data need to be in a structured way so that we can analyze that data and do some depiction, and then based on that we can make some analysis out of it, right? But this is the fact that we capture the data because we wanted to do business decisions. Until unless we don't have any idea behind it, why would we capture it? So there is very, very huge amount of data that is already available, right? So this huge amount of data is there that being captured by us. Once we capture the data, what we want is that data we wanted to do decision making. Decision making. Now, the problem with the data in order to do decision making, because they are very high in volume, volume, velocity, and the type of variety of data is there, veracity in the data is there, we cannot directly do decision making with that. We cannot do directly decision making. If we cannot do directly decision making, what the process that we're supposed to gonna achieve? So that's why there is a role of a data engineer scheme. Okay, our data engineer's role is, as I mentioned, they collect the very huge amount of data, they store the very huge amount of data, they clean, they profile the data, they pre-process the data, and they store the data into a certain place where this decision making, or you can say visualization or presentation can be happen in a better way, in a better way, right? If anybody have any question, did you understood why we want the data should be taken, and what is the idea behind to do that? The idea is simple. We want business decision. We wanted to use for decision making for any machine. That is why the data engineer role came into the picture. Got the point? Please type Y in the chat box if we don't,
Yes.
if you don't have any question. Yeah, thank you.
It's got it.
Got the point. Now, let me just quickly tell you what is the process that a data engineer follows. What is the process basically a data engineer follows is, just a second, let me. Yeah. So in the data engineering, when somebody is a data engineer, there is certain way they behave with the data. The very first step a data engineer do is called, they have to have some certain data. Okay, so data is being generated by multiple ways. It can be generated from any way. Either you are doing a survey, either you're collecting the data from any API, either you're collecting the data from any other number of sources, or from cloud, from variety of process they do. So the very first thing they do is called, they do data ingestion, right? They need to ingest the data by multiple way. Okay, they do data ingestion. Data ingestion is nothing but it's a collect raw data from various of sources, right? Okay, before I actually proceed, the today's session is a complete basics theoretical. Why? Because we want to set an agenda. We want to make everyone to understand the core concepts, whatever we supposed to gonna do that. So don't feel that we are discussing theoretical. It is very important for those who wanted to learn the high level thing as well as. So, okay. So the very first thing is called data ingestion. We ingest the data from varieties of sources, right? What we do next, once we ingest the data, what is the logical thing? Anybody would like to explain? Hello?
You clean the data,
Cleaning the data.
cleaning, transforming.
Okay, there is a bigger challenge in today's world because the amount of data is so huge. We are
Storing the
ingesting the
data.
data from variety of sources. You are ingesting the data from CSV, from API, from like from clouds, or maybe from survey, or maybe from sensors, from anywhere. You have varieties of data and you're ingesting. The bigger challenge to previously, when we don't, today we are talking, I'm talking about a conventional data warehouse. So you need, once you ingest the data, you need to store the data someplace. And the place where we dump all our type of data, either it's a structured one or unstructured, what we call it?
Data lake.
Amazing. So the place where we dump all our unstructured, structured data is called data lake. Okay. Yeah. So the very first thing is called data ingestion. We ingest the data from variety of sources. Okay. Once we ingest the data from variety of sources, then we put into a data lake. So data lake is a place, or you can say that a storage services, or a any you can say that a place where we dump all our structured or in a structured data. So if we talk about cloud, in cloud services, data lake, if AWS you use, you have S3, you have many data lake services are there. If you talk about Azure, we have storage services, blob storage, Delta Lake, and so many places that we can store the data. So data lake, sorry. So, there are so many data lakes available on cloud services, and even you can store into other places as well. Now, once we have a data view, once you got all your data, now what we do is we do process that's called ETL, So I believe everyone aware of this term ETL. ETL is what?
Extract, transform, load.
Extract, transform, and load. Why we call extract, transform, and load? Hello?
Yeah, extracting the information from the structured, unstructured, or semi-structured data, and after extraction, maybe any transformation, maybe minimal or maximum. Minimal means like null checks and data type transformation, and also any other kind of transformation like aggregations. All those things will perform in the transformation stage, and after that, finally, we load into the target. If it is an ML consumption, we'll again store to Delta Lake. If it is for analytical, then we'll store in data warehouse.
Correct. So, of course, we do extract, transform, and load, in which we first extract the data so that the data, whatever the amount of data we had, at least we can actually look around, either it's a structured, unstructured data or any place, we can actually put it around. And then once we put it around, then we talk about, we transform with some certain process, we clean the data, we actually make it use of, in detail, a way of, making the data into validation stage. We validate the data, we transform the data, we do some data aggregation, we do data loading. So ETL is a place where we do multiple things. We actually do data validation, we do, data cleaning, we do data transformation, we do data aggregation, and then data loading, right? So this is the idea, means we do that in ETL. Now, what ETL is actually doing for us is, once we do the transformation and load of data, this allow us to prepare a data to be in our desired form, because the amount of data was so high, we wanted to make a usable data, usable column into certain way, okay? And once the desired form of data we have, what is the next thing we do? Where we put this data? Hello?
We try to make sense of the data.
Data warehouse.
Very nice. Amazing. Once the data is going to be transformed, prepared, we have to store a data into a place where the data is actually stored for analysis purpose. Okay. So we store a data into a data warehouse. Okay. So I will explain you what is data warehouse. This is on a topic that need to be discussed. If anybody would like to explain what is data warehouse? Hello?
Data warehouse is where we have a huge collection of the data which are being extracted from various different source systems which are integrated and put it into a database out of which we can kind of build the data marts with the available data sets there, and that can be used for analytics purpose.
Okay. Yeah, I mean, we can say that data warehouse is a, you can say that the place where data can be stored, into for analysis purpose, OLAP purpose. Okay. So data warehouse is kind of a, it's a optimized, structured datas, are placed for business intelligence purpose. So data warehouse is a data structure that is optimized for use of business intelligence. Okay, I will explain you a bit on data warehouse because that may be required. I wanted to give you some certain understanding between RDBMS, data warehouse for everyone, because everybody can get a flavor of the understanding of OLAP, OLTP. They can get an understanding of why we require data warehouses, what was the conventional data warehouses, why we are using now, how we are using now. So these things need to be required. Okay, good enough. So once we store the data into data warehouse, the data are actually stored into a format where anytime any kind of data are there are into as in such a schema, okay, that anybody can do analysis. Anybody can do analysis. Okay. So then what is the next thing that we do? We can do analysis and visualization. We can do visualization. We can use any tool, either you can use Power BI or any other tool to visualize the data. Okay. Or on the top of it, you can do AI, data intelligence, or the advanced Gen AI, deep learning kind of thing. Whatever you wanted to do that, you can do later on. Are you getting my point? Yeah.
Yes.
So this is the idea. Means once you have a data, as a data engineer, what is your role? You will be first going to import the data. There is a data ingestion task. Okay. Data ingestion task is itself, there are a lot of tools are available. With the help of ETL tool, you can do all the data transformation, loading and all. Then you put across the data warehouses, and then you do analysis, visualizations, and then the data science team further will do analytics, and once machine learning algorithms and artificial intelligence need to be done on the top of it. So this is how the data actually flows. This is how the whole processes actually flows. This is the idea.
I mean, the AI modeling can still be done using the data warehouse itself, right? So it may not be uh, directly the data marts which will be used for visualization. So the AI modeling. So what that needs is basically the pre-processing of the data needs to be done in order to use that
Of course,
for AI
I've
purpose.
not explained this. Basically, there is a further concepts of data science is there on the top of it. Okay.
Mm. Mhm.
So if you guys are okay, I can actually explain you what happened to AI, just a 5 minutes. Let me just quickly tell you. So what happened when you have a data in data warehouses or any other places, in data science or AI, what we do, there is a complete data mining thing happen. Okay, the complete data mining happen. In data mining, we do data pre-processing, feature engineering. We do, multiple pre-processing techniques like we have multiple. If I talk about, we do standardize the data, statistically we correct the data. We do transformation, multiple other transformation. We do principal component analysis. We do multiple feature engineering techniques to prepare the data in as such a way. We do scaling. Okay, we do multiple scalers are there, that is preparing data for our required format. If we are doing computer vision, then there is another sets of data mining techniques being applied. So these things, when the data is prepared, you do advanced EDA on the top of it, as well as data analysis need to be advanced EDA being happen on the top of it. Once this happen, then the further machine learning algorithm is being applied. The further supervised and supervised reinforcement algorithm being applied. The further in before that, even though the neural network can be applied, and that is how the AI things happen on the top of it. So this is how actually the reporting thing on the basis of AI being taken place. Yeah.
Yep.
Hi Dipesh, I have one doubt here.
Please.
So actually, for ML consumption, right? We'll use usually use data lake, because if we don't have requirement of analysis, then data warehouse we won't use, because
Correct.
data warehouse is costlier compared to
Of
data
course.
lake, right?
Yeah.
So for ML consumption directly we can use data lake, right? We don't need data warehouse. That's what my understanding is. Correct.
No, I will not say it's absolutely, it's absolutely correct. But what we have observed is that, like, see, it totally depends on the kind of project you are doing and the kind of case study you have. If it's a core, you know, advanced machine learning project or a deep learning project, there the kind of data sets or the amount of data set being involved, we try to do our own data cleaning and all the stuff we do, and directly taking from data lake also. But if it's a analysis project, or you can say machine learning project in which certain recommendation system or certain, you can say advanced text analysis or NLP kind of thing also sometimes happen. We also take from data warehouses. The reason behind that is data warehouse having certain cleaned and verified data, right? So when we have cleaned and verified data, either talking about information retrieval techniques, either you are acquiring kind of a clustering technique, is more, prepared, confined way. Okay, because uh, you know, I don't know like how much amount of data you have been dealt with, but when that huge amount of data is there, again and again repeating those application on data, it it's a very costlier in those cases. So yeah, that is my observation. You can tell me like what you
Yeah,
have observed.
actually, when training the model, right? One time we need to pre-process the data. After training, we'll just use those models, right? So
Hmm.
we don't have to go again and again pre-processing steps. That's what I think.
Um, we'll discuss this by doing some kind of case studies. I'll tell you why sometimes it's required
Yeah,
and sometimes it's not. So
yeah,
we'll look into that. But
yes.
yeah, it sometimes depend on, we do cost estimation of our like whenever we do projects and all. What is the idea? The idea behind to tell you the whole thing is what is how we do data engineering. Okay, so how do we see this part is not yours as of now, but at least till here, till the reporting, this actually applies. This whole application applies till data warehouse, and the further BI part, people BI actually work around it. Okay, this is what actually being done. So this is the idea. As a data engineer, you're supposed to gonna do that. And the further ML have a lot of other assumptions. It depends. Data science is another field where there is a lot of discussions are there. It depends on the kind of algorithm we are using also. Sometimes we need to modulate the data. So we can discuss. I'm expert. Do have expertise on that also, but that's not required as of now. We'll see around with some applications.
Yes, sure.
If you have any questions, what we have discussed as of now in data engineering, any one of you can ask. Good enough.
So, Deepesh, I have one question. So, you have talked briefly about the data lake here. So, would you be kind of also discussing on the different layers in the data lake, specifically when the data is extracted and till the time it is moved to a area where it can be used for analytics, right? So in between these two, so would
I'm
you be kind
supposed to
of
gonna talk about data warehouse, okay, in detail, okay, the different layers of that. In between, see, I will also going to talk about the, the conventional data warehouses we had and the today modern data warehouses. In the
okay?
data lake is also present. So what are the different data lakes on cloud services are available, either in Azure, AWS or and all. So I will be discussing that part.
Sure, sure. Thank
Yeah.
you.
Okay, just allow me 2 minutes. Let me come back. Huh? So, okay. Uh, I'm supposed to gonna discuss about now a little bit detail about the basics and how the data warehousing actually happening, because you know a bit of the data warehousing, because that is very important to understand before we actually talk about data engineering whole concepts. And what are the, the different modes, and how the whole data base was replicating, and in data warehouses, because we are more talking about the analysis part in these days. So that is the idea. Let's see. See, one thing, let's discuss this, right? We wanted to do data engineering, right? So what was before data engineering? When What was before data engineering? Like today, we have a lot amount of data. But what was before that?
Data warehousing.
Databases, structured, unstructured.
Correct.
Yeah.
So the whole idea of the concept of data engineering, data warehouses came from to store a data. Okay. So what happened? Previously, when initially we started making computer programs, we started making softwares. We want to store our local data, like if it's a software, that's related to library. So we wanted to keep records of all the data. That is how the concepts of DBMS come into the picture. Okay, database management system come into the picture, and the idea behind database management system was to store the data and get the data to be like whatever transactions we are doing, whatever kind of interaction between software being done, all the records will be stored in our certain database, right? But later on, we realized that that database, keeping all the databases and doing some kind of a, taking information, analyzing those information in databases, because the amount of data is getting increased, it's becoming hard to, work around on databases, because database was primarily made for transaction purpose, okay, or primarily made for OLTP purpose, okay. So then we come across the data warehouse idea, okay, and with the help of the advanced RDBMS, and then MongoDB, and multiple tools we got into the picture, SSIS, SSAS. With those tools, we started doing data warehouse. So as a data warehouse, there was a concept. So as I mentioned, data warehouse is nothing but storing a data. A data warehouse is a data structure. Uh, Let me write here. A data warehouse is a data structure. It's a structured data that is optimized for business intelligence activities. Okay. With the help of data, now in DBMS, we were able to store the data. Whatever transactions are happening, all the records are being stored. But that was not enough. Later on, we started utilizing this. We want that data need to be analyzed. Okay, that data need to be analyzed so that we can do kind of understanding what is happening with our business. So when this problem state come into the picture, DBMS was not so capable. That is why the data warehouse concept come into the picture. So we want to store a data into a central location where all the consolidated data in an organization could have multiple, operations. So all consolidated data from multiple locations, from multiple database, are stored in a data warehouse, and that is maintained separately from any organizational data warehouses that we have, and all the end user can access it from whenever any information is needed by doing some basic analysis on the top of it. So that was the idea, and that's what we did in we wanted to do into data warehouse. And this is what we have done is, like, we required a data warehouse to stored to do analysis. So data can be collected from various sources and stored into a various databases. Okay, that's what we wanted into the data warehouse. So how we did this, let me just explain you. Yeah, so in data warehouse, okay, few pointers we kept in our mind, that the data should be structured and optimized. Okay, so since we want optimized and structured data, we wanted to use for business intelligence. And the idea behind business intelligence is to, for planning, data gathering, analysis, or business actions. Okay, so business intelligence acts transforming any operational data, raw data into useful information, right? Now, so for data warehouse, okay, we want to analyze the data. And that is why the concept of RDBMS started failing for analyzing it. So in RDBMS, what we were doing in RDBMS, we were using OLTP data. Okay. So all of you know the concept of OLTP? Hello?
Yes.
Yes.
Yeah. So in RDBMS, we were doing OLTP. Okay. Basically, OLTP is, it's a kind of process involves for capturing, storing, and process data from transactions. Let me write here. OLTP, online transaction processing that captures, stores, and process data from transactions. Okay, so this OLTP contained current data, any current data that we have. Let's say in a bank, if any transactions happen, that will be stored into a database, right? This actually help. Let me just tell the difference. So if it's a RDBMS, my screen is visible to all of you?
Yes.
Yeah.
Warehouse. So yeah. So OLTP is primarily for transaction processing, whereas this data warehouse is majorly for OLAP purposes. OLAP stand for Online Analytical Processing. Online Analytical Processing. So this RDBMS contain current data and this current historical data. So, like whenever any transactions completed and all the historical data will be present into that, right? So this actually help to any kind of a running business, like any kind of a interaction between users and the software or a application is there. So RDBMS was majorly helping us into running a business. Okay, running a business, whereas data warehouse is helping us to analyze the business to make a decision making capability, right? RDBMS run on certain work with ER model. You know that ER model, all of you?
Yes.
Yes.
Yeah?
Yes.
It's in a schema, certain schema, in a certain relationship model that's called entity relationship. Entity relationship. And if anybody would like to ask me a question, you can do that in between also. That's not a problem. Yeah, good enough. So let's work on ER model, whereas data warehouses have their own schemas. The schemas like star schema. Okay, we have fact constellation schema. We have other schemas as well as. Okay, so star schema is there, fact constellation schemas, and there are a few more schemas are there, right? So in data warehouse are primarily being able to store the data from 100 GB, to now we have very powerful one, but previously we are from 1 TB to 100 GB data warehouse was there in beginning, right? And whereas RDBMS was capable to store 100 MB to 1 GB of data kind of thing. So previously that was the capability, but everything now today based on cloud, everything can be scaled, everything can be maintained in a better way. So that was the idea. Now RDBMS keeps low data, okay, less data, so that the speed is faster here, faster speed. Why? Because the transactions are happening, amount of data is less. That is what. But here, data warehouse, you can scale now. It's a flexible nowadays. We can increase the speed based on the processor we can use. So it's totally like flexible in today's days, right? So that is the difference between data warehouse and RDBMS. And as I mentioned, analytical processing is happening, complex query we can analyze using historical data of OLAP that is being done here. Uh, so Data warehouse, if I talk about the architecture of data warehouse that we have today, let me just show you something. Some My screen is visible.
Yes.
Yes.
So as you can see that data is collected from a variety of sources, and database cannot be directly visualized. The data first need to be integrated and then processed before visualization take place. So we collect the data from different databases, we store in our data warehouses, and then we do visualization into data warehouse, right? As I mentioned, what is business intelligence? Business intelligence is nothing but its act of transforming raw operational data into a useful transformation for business analysis. How does it work? BI based on data warehouse technology that extract information from a company operational system. The data is transformed, cleaned, and landed into a data warehouse. This is how it's being done. Um, this is what I mentioned here. Data warehouse is a data structure that is optimized for use in business intelligence activities. It is stored in standard databases, and we can get the data from either CRM, ERP, we can get the data from sales, we can get the data from HR, finance. So we can actually get the data from varieties of sources and store the data, so that, optimized data can be prepared. That's what we do. It brings cleaned, verified, and standardized data. It stores historical data as well as the structures are highly optimized for ad hoc queries, and it is not optimized for transaction, as I mentioned. This work on a concepts called data marts. Correct? So this is the presentation of, architecture, you can say that, of a data warehouse. Let me quickly explain you those who are new to this. Okay. So basically, this is a kind of a conventional data warehouses. Okay. So data is being collected from varieties of sources like RDBMS databases, files, cloud stream, data sources. Okay. So from varieties of sources, data were getting collected. Okay. Now, after that, data next move through, there is a tool, SQL Server, we were using. So, data warehouse in today days, we have cloud data warehouses are available. We have variety of tools are there like Informaticas and all, and Snowflake is also one of the tool. Previously, we have, even though now SQL Server and all those who are using, that we put the data, we collect the data, we ingest the data. So data next move through SSIS, SQL Server Integration Services. Okay. And then we do ETL, we extract, we transform. And there is a very, very huge data and extraction being happen, right? Then in the conventional data warehouses, there was a staging area. Who gonna tell me what is staging here?
Where you dump all the data in raw format.
It is analogous to the data lake in the current architecture.
Correct.
It's intermediate data dump or storage. Yeah.
Correct. So it's a temporary storage for while we are doing the processing. Okay. Or you can say it's a landing zone. It's an intermediate landing zone storage are used for data processing for doing an ETL process. Right. Now, once it's there, then once you do staging, then there is a we in staging in between also, while you do ETL, we also have a ODS data. We have also operation ODS data are also there. So what is ODS data? Anybody aware of that?
Operational data source.
Correct. What is the meaning of that?
I guess it's the transactional data, the daily data.
Whatever transactions has happened. So it's having a latest snapshot of data. Okay. So, once it is being done, when it's been created, Then that data goes down into the data warehouses. In data warehouses also we have varieties of, here if I say that, let me just write here. So here, oh, yeah, I'm talking about this, right? So once you have this, once the data is here, we put into the data warehouse. In data warehouse, there are different data marts are there. I will be explaining you a bit on this. So we have different data marts are there. In this data marts, which can be a smaller version, you can say that data marts are nothing, but it's a smaller version of data warehouse, which contain focused in one area about the data, that is being stored inside the data warehouses. And then the further, with the help of tools like SSAS analysis services, we put that whatever the semantic layer we have created, in which the multi-dimensional data are stored, and then this will be accessed further with the help of Power BI desktops, and then we do visualizations, right? So this is an architecture of a conventional data warehouses. You have any question?
Can you explain semantic layer a bit?
So basically, in the conventional architecture, so what basically is there is, once the data's, is being captured, into this, we store the data over there. So, we have to put the data for analysis purpose. We have created the data into multiple data marts inside the data warehouse. So, while we are using services of SSIS and all, we need to prepare a data so that it can be get taken by any analytics tool. Okay, the semantic layer created in as such a way, so that the data are formed into a tabular one, okay, to be accessed into multiple schemas that is prepared inside that. And this semantic layer is allowing further tools, further visualizations tool to access and then can be visualized further. So different SSAS layers are there, that's preparing the data that's inside that, and letting to do further analysis on the top of it.
Basically, the semantic layer works on the top of data marts you are saying, right?
Hello.
Present in the data warehouse.
Yeah. So, the semantic layer having capability for data abstractions, kind of a data aggregation. Okay. Hierarchies and dimension can be created. Securities, ensured by this. These kind of things are there, and allowing integration with BI tools. So these are the, let me write here. So basically, this semantic layer, can do abstraction, so it's hide the complexity of data sources and providing the user friendly way to query the data, so that user can interact with the data in a familiar business terms. That's what the data abstraction will do. Aggregation, so that SSAS can allow you to create pre-calculated aggregates, so that the further analysis can be done on the top of it. So these features will be given aggregation. And yeah, one more amazing thing is creating hierarchies and dimensions. So we can define hierarchies, let's say in year, quarter, month, geography. These kind of things will be there. So that's how the hierarchies can be created on the top of it. And SSS having a security feature, that's ensure only and only that access can be happen to this permitted person or permitted access. So these are the stuff are there.
So basically, on the top of data mart, we will use this semantic layer, so it can create the visualization tool, because these things are normally done visualization tools as well, right? Aggregation, etc. Okay.
Yeah. So it's a kind of a, you can say, plugin that's helping other visualization tool to access the data in a better way with the help of SSAS. For the point?
Yeah.
Yeah.
Okay, and then further, there is a Power BI or any other tool that's allow you to do kind of a business analysis purposes and all. But yeah, there is a concept of data mart is there, inside the data warehouse. Let me quickly explain you that will help you in some way. So as I mentioned here, oh, this need to be cleaned up. How to clean it? Okay. So as I mentioned here, in a data warehouse, if I talk about a data warehouse, as I mentioned into this, the architecture, there was kind of a data sources, okay, data sources. Then we had a, like we do ETL. This is a data flow I'm talking about. It's a ETL process we do. In ETL, as I mentioned here, there's a data validation. There is a data cleaning. There is a data transformation. There is a data aggregation. There is a data loading. Okay, that is what happened. And then we store into a data warehouse. So a data warehouse is like this. So data warehouse consists lot of things like this. So there is a data mart. Okay. And so basically, when we talk about data mart, so data mart nothing but it's a, you can say that, the smaller version of, of a data warehouse. So data marts only focused, let me write here. Data marts are focused on one area inside the data warehouse and use less time to create and can only be accessed for a less memory. Okay, and that is why there is a difference between data warehouse and data mart. Sometimes we can directly create data mart itself. In data warehouse there are data marts, but you can directly use data mart itself and can be directly created also. So data warehouse is enterprise level data. A data mart represent a specific department or data. Data warehouse can be accessed from multiple data sources, where data marts have only single sources. And because of that, there are different types of data marts are also there. So if you are aware of that, different types of data marts, are you aware of dependent data mart, independent data marts, or hybrid data mart? Anyone?
No, Deepesh.
So dependent data marts we have, then we have independent data marts. Okay, so dependent data marts are like this. We have any OLTP sources, let's say any OLTP sources, then we put that data into a data warehouse, and that is how the focused data marts been created. Data marts are there. Okay. Whereas in independent one, we can directly create from any OLTP sources. We have OLTP sources. You directly create the data mart from this. Okay. Then there is also a hybrid one. So hybrid is like you are also taking from, okay, from data warehouses or any directly OLTP sources. So that is how the, like the hybrid one is being created. So there are three different types of data marts. Yeah.
So Deepesh, this independent data mart, what you explained is looking similar to what a data warehouse we have. So is there any difference, or is this data mart, even though if it is extracting data from OLTP, it is focused on only a smaller size of data? So how
Yeah.
is it different from the data warehouse?
See, first of all, you need to understand what is the difference between data mart and like data warehouse difference. So data warehouse is the organizational data, whereas data marts are focused. But when it has been taken from any direct OLTP sources, so data warehouse is a centralized repository that is store integrated data from varieties of sources and all, right? When we are talking about independent data marts, right? So independent data marts, as I mentioned, that is, like built and managed independently from other systems, So it is taking the data from OLTP sources directly, but a focused area has been taken up. Like any sales data of being taken up from that OLTP sources. Question answered, or do you want me to explain more on it?
I would actually need a more explanation on this.
Okay, see, let me just quickly give you. See, let's suppose if there is an independent data marts, right? So independent data marts is a specialized subset of a data warehouse. Okay, it's a always remember data marts are inside the data warehouse. Either it's a dependent, independent, or anyone. But that has been taken up from OLTP sources. So basically, independent data marts, it's a specialized subset of a data warehouse that is created and managed separately. Okay, managed separately. Uh, but it's having said that it's having a particular department or business unit, unlike the dependent or logical data marts that we have. Okay, so but this independent data marts is created directly from data sources. Okay, it's having the logical data marts only of a specific business use cases, but it is being created from a direct OLTP sources of a, let's say, called sales data. Okay, sales data. But if it's a data warehouse, you are saying what is the difference between data warehouse and an independent data marts? Data warehouse consists of multiple data marts, right? And that is also taken from OLTP sources. But this OLTP sources is this data warehouse taking from all the varieties of types of OLTP sources, from not from one OLTP sources, rather from varieties of OLTP sources. So that is why it is autonomous structure, a specific focused one. Quick deployment can happen. Okay, and that is the idea only when we are creating this independent data marts.
Deepesh, does it mean like whenever we take the independent data mart from the data warehouse, so it can be easily suitable in another data warehouse, like the schema and everything?
Yeah, I mean, see, it can be fit over there. Like you can easily understand by an example. Let's suppose there is if you are talking about an independent data marts, so it might be implemented by a marketing department. Like, so let's suppose if they wanted to track and analyze campaign performance, okay, since that particular departments need to quickly access to data without waiting for the IT team, because otherwise we need to get the data from data warehouses and then wanted to make a kind of a approval, and then further analysis been taken up within the schema. They wanted to take that data marts, and that's how they actually use this. But if they have created this independent data marts for any marketing performance or anything like that, so they can quickly access data without waiting the IT team to integrate into a central data warehouse. So they develop their own independent data marts. This allow them to quickly generate reports or gain insight specific to their campaign. And one thing I believe you might have a question about the schema of it, right? that how this schemas is running around. So independent data marts providing quick and focused way of all the schemas as well as why? Because while you're creating this, the consistency between the data is not, lagging, because it's a conceptualized view of the data that you have abstracted from the data warehouse itself. We'll do one thing, see, of course, when we have some certain data, we'll try to create over there and we'll try to pick it up. That's how we'll be able to understand. That will help.
Yeah, that helps.
Hey, Dipesh, sorry to